Hello everybody, where's the camera? There's the camera. Usually you just get to see the workbook and hear my voice or somebody else's voice, and you get to see the workbook, but today I actually have some props that I need to explain to you what circulation of a vector field is. So I will need these props to explain that to you. So this is the beginning of section 20.3, and I'm sorry if I'm not looking at the camera always, because the camera is at that side right there, and I'm looking at what's behind me. Sorry about that. Okay, so to explain what circulation of a vector field is, I made a little toy right here. This is called a pedal wheel. This is gonna help us figure out how much circulation there is in a given vector field. So I have two vector fields on the board back here, and the left one, let's look at that one first. So imagine it's a river. Imagine this is a river, and so these vectors right here are actually velocity vectors. So over here the velocity of the water is large magnitude, so it's moving pretty quickly, and then over here it's moving more slowly. We have shorter velocity vectors. And imagine we have a 3D situation right here, so all of that would continue in this direction. So it would just be parallel, or the vector field would be parallel in this way. So we basically have flow in that direction, strong flow over here, less strong flow at the bottom. Now, it looks like there's nothing circulating. We don't have any twirling going on in this vector field. But what we want to measure is if I take this pedal wheel, and if I put it in different positions inside this vector field, will it turn? Will there be some kind of movement going on? Will there be rotation? And so I'm asking you, if I put this is my river, this is like a little water wheel. Imagine I put it in this river. What do you think is going to happen? Is this going to move this way, or is it going to move this way, or is it just going to stay stationary? That's the question that we are asking ourselves. And so over here, again, up at the top, there's water pushing against these blades right here. At the bottom, there's also water pushing against the blades right here. And if the strength of the vector field was the same at the bottom and at the top, probably no movement would be going on. But since this particular vector field right here, it's much stronger at the top than it is at the bottom, I would expect my pedal wheel to move this way. There would be some rotation going on, because more water is pushing up at the top right here than is pushing in the other direction down here. So it would actually turn this way. Now, depending on your point of view, there's also a direction associated to how your wheel is turning. And so imagine we're looking down the handle of the pedal wheel. So I'm putting my eye at the top of the pedal wheel, and I'm looking down the pedal wheel, and then I see that this is clockwise movement. Clockwise movement is going to be negative circulation. If I turn this pedal wheel around, what would happen? If I turn it 180 degrees, it would move this way. And when I put my eye on it, now I see counterclockwise rotation. And counterclockwise rotation is positive rotation. So I see that I have rotation going on right here. I could put my pedal wheel any way I wanted to. I could move it around however I wanted, and depending how I would move it, my pedal wheel would probably move at different rates, quicker, or I would have high angular velocity or low angular velocity, or maybe it wouldn't move at all sometimes. And so that is what we're going to measure in this next section. We're going to measure if we are putting a pedal wheel inside of a vector field, is it going to rotate, and if so, in what direction and how fast? So let's look at one more example. Over here I have a totally different vector field. I tried to draw it 3D, and it's actually the same vector field that you can see on page 151 in your workbook. So it's twirling. It's like a 3D thing, and all the vectors are twirling this way. So you can imagine if I put my pedal wheel in this way, and there is this twirling going on, yeah, there is strong rotation going on. It's going to rotate this way. And the question is, what direction is that? Well, let's see. I'm going to look down, and I see counterclockwise rotation. So that's positive circulation. If I turn my pedal wheel around, I still have movement this way, but now when I put my eye and see how is it rotating, now this is clockwise rotation, and so that would be negative rotation, negative circulation. Okay, I'll meet you in the next video. Oh, no, one more. What if I did it this way? What if I put in the pedal wheel this way? So there is this circulation going on. I mean, my vector field moves around in circles this way, but imagine I'm putting in the pedal wheel this way. Is it going to move? So this is how the vector field moves everywhere. Even though that looks very swirling, in this particular direction that I'm showing, or even in that direction, there would be no movement going on at all in this vector field, because it's going it's not really touching the blades, it's just going around this way. All right, I'll see you again in the workbook in a little bit, and then we're going to see how we can actually calculate the circulation of a vector field.